All right, so let's get started with our next speaker here. Mehdi Raza Jaffery is a Chief Product Architect for APIMatic. I'm going to talk about demystifying the API onboarding. Mehdi, you got the floor.
Great. Okay, so if you have an open API spec, what you can do is you can upload it to APIMatic and it will give you auto-generated SDK, that is client libraries and API documentation. I work on the API code generator team as well as the API portal generator tool that APIMatic has, and I also work as an API evangelist. So a quick outline of what I'm going to talk about. First, we'll see what are SDKs, why are SDKs needed, and then I'm going to talk a bit in detail about how to make great SDKs. So what are SDKs? Software Development Kit, or SDKs. SDKs, everything that you need to write API integration code. So if a user is trying to integrate your API into their application, what do they see when they visit your product or your marketing site? Everything that they see is going to constitute their software development kit. So you have the API consumer who has to build an app using your API, and they need a couple of stuff to make that. First, the software development kit has client libraries. So that's language-specific code that they can pull into their code base to write their API integration. And to couple client libraries, there's also language-specific documentation. Language-specific documentation is made up of guides that show how to use client libraries, and it also has an API reference so that you can explore what endpoints exist, how I can write code in my application for those endpoints. And it also has some copy-ready code samples that you can copy and pull it into your application so that you can call that API. Client libraries are language-specific. That means that they provide code specific to a language. So if you're using a PHP client library, you would have methods, classes, everything that would be needed to write and call an app that uses that API. Client libraries try to make calling an API as easy as possible. And how do they do that? We are going to visit why SDKs are needed. So a typical user, this is what a typical user's journey looks like when they're trying to use an API. I've taken an example of a payment API. You have a neat written payment API where they have payment, billing, receipts, everything that a normal payment API should provide. And then usually it is exposed as a REST API. However, the REST API has its own language. The REST API talks in terms of routes, it talks in terms of HTTP method, headers, JSON. It's a whole different language compared to the product that you're exposing. And at the end of this whole API journey is the user's application, which is actually what the user is trying to write. And between the user's application and your product, there's a wide chasm, and that wide chasm is the REST API. So although all they care about is integrating your product in their application, they still have to think in terms of REST API every time they're trying to use your product. And that's a whole different language that they are working in, and it's a whole different set of language that your product is defined in. How can we make this easier for the user? Everything that they have to do, they have to first translate in terms of an API call. They have to think in terms of form parameters. They have to think what query I'm going to use. They have to think of what route I'm going to call. Although that doesn't really matter, they just want to call your product and get their work done. To make it easier, what you have to do is that you have to provide SDK, software development kit, that wraps away and abstracts away that middle segment from the API onboarding journey. So API integration is really hard because it is one of the most expensive thing for the company that is writing an application because it consumes developer time. So it also deserves the most effort from the part of API providers as well. And that effort has to be in the form of software development kit. How do other companies tackle API integration? How do they make that easier? As an example, I've taken a screenshot from Stripe, and what they have done is that they show SDKs in the very first part of their documentation because they know that SDKs is the best way to get started when someone is trying to write API integration. They also provide language-specific documentation. So if you visit their API reference, you're going to see code sample for each of these languages in their API reference. So it's not just a generic REST API reference. You have code sample for PHP, Java, inside this documentation as well, which you can copy into your application to quickly get started with the API. And I see this pattern occurring in other API developer portals as well. So for example, Square also has a SDK first documentation, and Twilio also does that. Why is that? Because these API providers have realized that although API delivers the product, the real interface to their product is the SDK, that is the software development kit. So if SDKs are so important, what can we do to make great SDKs? So my team at APIMatic is responsible for generating SDKs, which means that we design the SDKs in 6 languages, and we do this for other API providers. But we not only design these SDKs, we auto-generate them as well. So we have learned a lot from our journey throughout the years. I'm going to share my learnings very quickly in this talk. So the first rule that my team has that SDK should speak the language of their developers. That means when an SDK is being used to integrate an API into a product, it should not talk in terms of REST API. It should be REST agnostic. That means a code sample that is littered with details of routes, it is littered with details of JSON requests being made, is not the right kind of code sample that you should be showing to an API developer. The code sample should be REST agnostic. That is, all those details should be abstracted away by the SDK. This means that the user does not have to know what route they're calling, how the request is going to be made. All of that is wrapped away, and all they need to know is how to call your API and just pass the right information to it. The underlying network request is hidden away from the user. Not only that, SDK should also be idiomatic to the language. That means if you're creating a SDK for C#, it should have async methods because that is what the developers of that language expect. And it should have it should follow the guidelines for that language. So if the C# language uses Pascal casing, then that is how your SDK should also be designed. This is all working into how SDK should talk in terms of the developer's language, which is the code that they write. SDK should also be consistent with the API, which means that you should have a near one-to-one mapping between what API calls exist in your API and how your SDK is designed. This helps people transition from an existing API integration code that they have written to using your SDK. And this also helps create a pattern so that if they're working with one part of API, they can also shift to another part because it's all consistent and it's predictable what calls they need to make. Another rule that my team has for creating great SDK is that every SDK we create should make API integrations happen faster. How do we do that? We have simplified the SDK getting started guide into 3 steps. One is that you should provide an installable package to the user for the SDK. Then you should have a very simple setup process for the SDK. So in this case, to get started with Stripe, all you need is an API key. So that is how simple Stripe's SDK setup should also be. And to top it off, there should always be code samples that that a developer can copy into their code. So these code samples help them get started quickly by providing examples for common usage scenarios. Another good thing that an API provider can help their developers do is that they can help fight code decay. That means less refactorings for the user, less problems when they're migrating from one language version to the next, less problems when they're upgrading their dependencies. So one of the problems that you will have when you're creating SDKs is that you will see that the language that you're writing your SDK for is also changing over time. And that is where you help your developers. You make sure that your SDK is always up to date for that language. And if that language is introducing new features, you should also incorporate that in your SDK. But you should do that in a manner that does not introduce breaking changes. Sometimes that might not be possible, but there are always ways that you can mitigate the effect that it has on the users. SDK should also help API users navigate dependency updates, because over time, the dependencies in your SDK get out of date, or they might receive security fixes, or they might have bug fixes. So here's an example of what our team was trying to solve when we were releasing TypeScript SDK. We had, within a course of 3 months, over a dozen security vulnerabilities being reported by GitHub. And that was before we released the TypeScript SDK. It was still in development. So the writers of SDK have to protect their SDK users from having to deal with all of this. And they do this by taking care of this before this problem bubbles up to the user level. SDK should also help write API integration code that works in all cases. The API server can go down. Sometimes the network can fail. Sometimes there are problems with the API connection, or whether it's at your end or at the API server. What you need to do is you need to make sure that your SDK is able to handle all of those cases. So some of the cases happen when you're writing API integration code. For example, a user might be writing the wrong request. In that case, providing strong typing in your SDK can help catch those issues before the code is deployed. And you do that by providing strongly typed code throughout the SDK. This helps catch issues through compilation error, but it is also good to have runtime checks throughout your SDK as well, so that if there are languages where compile time checks are not available, runtime checks still catch issues like missing attributes in the request or responses that are malformed. Every issue that you catch is an issue that does not bubble up to the application level. SDK should also protect against the effects of distributed system. That means that every time there is a transient failure, you should have code built into the SDK to protect application from crashing. So if an API hangs or there is no request for 10 minutes, the application shouldn't have to wait for 10 minutes. You should time out as early as possible in a safe way. And if API calls can be retried safely, you should also have that built transparently into the SDK so that any API call that fails is retried without the API user having to worry about that. Some API servers also support API throttling and circuit breaker pattern. This means that in case there is a pushback from the API server that, hey, you have to slow down, you're sending too many requests, SDK should also be able to handle that pattern as well. Everything, again, that the SDK does here is to help protect the developer from making mistakes. That is, network code is really difficult to write, right? So SDK should make that easier for the user. So all these points, what we did is that my team also organized these into a matrix. This matrix is a matrix that shows what design principles we are aiming for when we are designing software development kit for APIs. And what you want is that you want SDKs to make API integration code more accessible, approachable, maintainable, robust, and reliable. And these are the ways that you can help make that happen. And that's not all, but you can think along these lines. For example, to help increase robustness of API call code, you can provide more API-specific error handling. So in case of a payment API, you might want to make sure that API calls are idempotent. So you build that ability into the SDK so that users have an easier time writing code against your API. So I hope that helps you write better SDK. But if you wanna automate all of that, if you don't want to write SDKs by hand, you can also auto-generate them using APIMatic, which kind of follows all of these principles that I was talking about. You get started with an open API file, and APIMatic generates the SDKs for you. And you can also reach out to me if you have any questions about from my talk. So thank you.
Great. Thank you, Mehdi. We have time for a question or two if anyone has any question. I do have one question about, you mentioned many of the stuff that really could be helpful within an SDK. In your experience, where to draw the line, what not to implement in an SDK, what not to implement, what not to encapsulate in that SDK? I see a lot of networking, circuit breaker, stuff like that, right? Maybe security, so in your experience, where to draw that line, how to decide what to encapsulate inside that SDK and what not to make that choice?
That's a good question. So what would you not put in an SDK? I would say that you keep your SDK as general as possible. Make sure that it applies to as many of your business use cases as you can make it cover. So if you are writing code that should be happening at the API server end, then that SDK is going to become complicated really fast. If there are things that should be handled at the server and they belong at the API implementation, and one of the examples that apply here is that API validation code should always happen at API server. SDK is not a good place to do validation for requests and responses. You should have basic type validation, but anything more specific, for example, checking whether a credit card number is 14 or 16 digit, that should always happen at the API server. And so this simplifies the SDK, and it always makes sure that your API server's messages about what error are there in your request, they are the canonical error messages. There are no two conflicting versions of what's wrong with your request. That's one mistake I see people making when they're writing SDKs by hand.
Very good. That makes sense. That makes a lot of sense. Any other questions before we wrap up?
Thank you.
All right. Thank you. Thank you, Mehdi.